Okay. We're live everywhere.
All right, we're
Hello.
live. Here we go. All right, this one time, episode. Jorie, what episode are we on now?
16.
16, episode 16. Here we go.
Episode 1.
Drive.
Yeah, episode one. Yeah, that's right. Excited. Yeah, welcome back, everyone. Yeah, and at this one time, just like a quick synopsis. Everyone talks about hardware being hard, and you know, our machine, we're definitely experiencing that. We're building a large robot to reclaim lumber from construction and demolition sites and put it back to work, working on this circular economy sustainability effort. Yeah, we like to chronicle our story here. We're sort of like bringing people along for the ride, talking about the challenges, the wins, the losses, the exciting moments that we have, so that, you know, maybe hopefully someone out there can learn from this experience or, you know, in the future share their experience. And it's all about just like getting information out there, sharing with the community, and just like helping folks get to their goals a little bit faster. Yeah, and today the topic, the title of the episode is Make Big Bird Soar.
Yep.
Yeah, and so as usual, we have Jorie Wisnefski, the marketing manager here at Urban Machine, who is like really leading the charge and keeping us honest on this one time. And for the first time ever,
Yep.
Aidan Barry
Yeah.
joining us. Aidan's on the hardware team, and you've been here since April.
April.
Yeah,
Early April.
early April.
Yeah.
Yeah. So, should we, Jory? Maybe Aidan, you can introduce yourself a little bit.
Yeah,
Sure.
Kick things off with that.
Yeah.
I like that.
I'm Aidan Barry. I'm a mechanical design engineer here. Previously worked in the Bay Area as well on some other projects, indoor farming, paper digitization. I went to school in Canada at the University of Waterloo. Andrew and I are both Canadians.
Hey.
And I grew up not too we're both Canadians, yeah. And I grew up not too far away from Waterloo in a small town called St. Thomas, Ontario. I guess some other things. I have 4 brothers. I grew up with a lot of brothers in my house, and we always liked building Legos, and I think that's kind of where my mechanical design journey started, as for a lot of other people. So yeah, that's a long-winded introduction.
Love that. I did not know you had that many brothers,
Yeah.
but that does make a lot of sense. Does anyone else build stuff? Like, are you all?
Yeah, in a way. My youngest brother is actually doing his engineering degree right now, computer engineering at Queen's, and then my second oldest brother is a civil engineer, but not practicing. So, yeah, some
They understand what
Lego
you're doing.
boys for sure.
That's awesome.
Yes, yeah.
Yeah.
Shout out to
Lego
Lego.
mints, yet another engineer. Yeah, absolutely.
I feel like
Yeah.
that could be a
So
really good
let's maybe.
survey to see, how many engineers liked Legos as kids.
And it's so common. I mean, I think at my parents' house, we got just like piles and piles
Mhm.
of it. It's just endless.
Yeah.
Yeah. Oh, did we lose? Did we lose Jory?
I still hear you. Nope, I'm here.
Are you there, Jory? Okay, cool.
Mhm.
Okay, cool. Yeah, so let's get into the topic
Do it.
of the episode. So this is going to be another 3-parter. So we did this with Gabby. Aidan, you're kind of on the sidelines of that project. And we're going to do the same thing here. We're going to talk about the problem today. We're going to talk about some of the requirements and like how we've ended up here. And then the next couple episodes are going to be sort of sussing out what the solution looks like. And then, you know, this will be interesting because I think this one, there's going to be potentially more lead time involved and
Definitely.
like more bringing things together. So it's not going to be kind of the quick turn that Gabby had on her project, but you know, we might bank it down, but we'll get there.
We can check back in.
Yeah, we'll check back in.
Yeah.
We'll check back in. Yeah, so we're going to do that sort of thing. So Aidan, you are primarily working on our robot gantry system that's responsible for actually pulling the nails out of the lumber. That's mostly what you've been working on.
Yep, also known as the Big
The
Bird.
Big Bird,
So
that's what we
where
call
the
it.
title comes from.
Yeah,
Yeah.
yeah,
So
we
it's
call
your
it the
job
bird
to
because
make it
the end
soar.
effector. Yes,
Sure.
yes, yeah. And one specific, extremely important component of the Big Bird is what we call the Z-axis.
Mm-hmm.
The Z-axis is the axis that is directly responsible for pulling the nails
Mm-hmm.
out of the lumber. This is yeah, where all the force goes.
Yeah,
basically.
and positioning the end effector in the right location as well in
That's
that
right.
in that axis.
That's right.
Yeah.
Yeah, and maybe we can just snap to the video just to give some context
Let's
because
do
I
it.
think that'll help.
Yeah.
Help just sort of plant what we're looking at here. So I'm just gonna attempt to
While you're
share
getting that
this.
set up, the problem is that, you know, we need these big birds to be pulling. You want to program it and make it go faster, yeah?
Faster and yeah, future proof it a little bit and pull a bit harder as well. I think
Okay.
ideally, not pull harder and also potentially push a bit harder for access to the nails and a variety of reasons. But yeah, so
Okay, so
the
push
two
meaning
main the two main things here are
okay, just to clarify
it
though.
means like move into the wood.
And it's for those metal fasteners that are very deep. Yeah,
Exactly.
got it. Okay.
Yeah, it's one of the tricky things that it's not just about pulling the nails. We also have to dig into the surface to get under nails that have been hammered all the way into the surface of the wood,
Mm-hmm.
right? So there's sort of like we have to be able to dig and pull,
Mm-hmm.
which sort of puts this extra layer of requirements around the whole problem.
Yep, and
Yep.
those two, that's kind of a way of framing the force requirements, I guess. And the
Sure.
other requirement is we're constantly striving to make this whole machine operate faster. So we want the axis to move quicker as well. So
Okay.
that kind of frames the problem, and like it's two main variables, I guess.
Mm-hmm. Mm-hmm. Yeah. So you want to get into a little bit about like where we are today, like what we're capable of today?
Yeah. So where we're at right now is we have an actuator that we've been using for, I mean, I guess the last year and a bit on the Z-axis, and it's been working pretty reliably for us. I think we're pushing a lot of the speed and force like limits on that, and we've seen some failures in the field, which are not ideal, and we want to where we're at is we're ready to, I guess, design the next iteration of the robotic work cell. We're kind of at the end of a era, I guess, of our type of machine. So we're kind of, it's our first opportunity to look at things from a fresh perspective. And this is definitely one of the areas where we want to make improvements. So this is one of the first projects that we're sure we want to pursue. And so that's kind of why it's a good topic for right now and why I'm tackling it right now.
As
Is because
as
we're
you guys
moving
are
into the
building,
next generation of machine.
right, as you're building 4.0. And that is
Mm-hmm.
on what already existed. So here comes your creativity to improve upon what already.
Definitely, it's my favorite time in the project life cycle as a mechanical designer. So yeah, super exciting. So yeah, we're looking to replace that actuator with something new and build a design around this product, which is very important for the success of the machine. So yeah, and that's where we're at.
Yep. Yep. Yeah, and so the current actuator, like you mentioned, we're operating at the fringes of its performance envelope.
Definitely.
And we know that there's scenarios where we could potentially tackle fasteners or tackle that like we don't want to go after them
Exactly.
because we would be then exceeding those performance.
Yeah, and potentially compromising the actuator.
Yeah, yeah. One of the things that makes this particular part of the design or actuator selection challenging is that the forces are high. Obviously, we're pulling nails, right? And we like our early experiments show that it could be over a couple hundred pounds of force, maybe even a few hundred pounds of force that you need to pull on a fastener in order to get it out. So like you're talking about high loads, right? Like and potentially unpredictable loads.
Definitely. And it's even hard to, because the way fasteners are embedded in the wood is so random, and it's done by, in the field, and it's hard to like predict what the highest load we might potentially see is even going to be. So you want to add what we have seen, you want to add some like generous safety factor on top of that. So that you are like future-proofing your design and not under-speccing this product that is expensive and takes a long time to get and is very integral to the success of the machine. So
yeah, and then of course the other side is the speed. Is that we want to be able to move quickly as possible because in any type of machine like this, time is money, right? Like we measure the success and the economics of the system by the throughput of the system.
Yeah.
And every fastener we pick is time spent on that piece of wood. So we want to reduce that pick time as much as possible.
And currently, it's worth noting, like currently that motion to move the Z-axis into position and out of position is the longest motion on any of our axes on this machine. So it takes up the most time. So we want to, reconcile that and make sure that we fix that for the next version. Yeah,
exactly. And I think it's like the X and Y positioning, like positioning over the nail is usually like we're at 0.7 seconds or so, somewhere in that territory.
Yep.
And then we spend something like over 3 seconds.
Yeah, 2 to 3
2
seconds.
to 3 seconds moving it. So the Z-axis is by far like, triple to quadruple.
And it really doesn't have to be that way. It's just kind of the reality that we've been stuck in for the last year or so with machine design and things taking a long time to get, and
and then so why is like asking to increase like maintaining high force and also trying to increase the speed simultaneously, like why is that, like what are you asking there, like why is that particularly challenging?
Well, typically when you're speccing an actuator, you usually get one or the other from whichever type of actuator you're selecting, whether that's like a ball screw or a lead screw or a belt drive or whatever. But in our case, we want both. So you kind of have to go to like a specialty type of actuator. And I think in a lot of the lumber industry, or wood processing industry in the past, like you see a lot of high force applications and you see a lot of hydraulic actuators. But kind of more recently, there's been a movement to these like so-called thrust actuators, which are a lot faster than hydraulic actuators and a lot more controllable, but provide the same amount of force. So that's kind of like the direction that we think we see ourselves moving in. And that has obviously a variety of benefits.
Yeah.
And it also increases the lifetime, which is another kind of requirement on our list of, our requirements variables.
Yeah. And one of it is, hydraulics is extremely like powerful, energy dense, but we also have sort of this running inside joke at Urban Machine that avoid hydraulics at all costs.
Yeah.
And we kind of jokingly say that internally, but like hydraulics are messy. If you've ever worked with hydraulics, like they're usually constantly leaking. They're hard to bleed.
A lot of maintenance.
That's what I was just gonna ask.
And ton of maintenance, and then they're not very energy efficient. You're wasting a lot of energy just into reservoir or just turbulence within the oil through these various so it's like a extremely energy inefficient actuator as well. So we try to, not only do we want to create a sustainable pipeline for material, but we want our machine itself to be as sustainable as possible.
Totally.
And we're going to be operating on remote job sites. Potentially, we don't have access to grid electricity. We might be running off a solar battery, so energy efficiency is always on our minds as well.
Definitely.
Yeah.
Yeah. And so that's
I saw the pictures of the solar panels that are running things right now during the testing. That's pretty amazing. So it's not just
super cool. I
yeah.
had a lot of people in my life were like, "Is your whole machine actually running off of solar panels?" And I was like, "Yes."
Yes.
Like a lot of people who like work in the machine design industry who I'm friends with were super perplexed by that, which is insane.
Our machine is so efficient.
So efficient.
Our whole machine uses about a kilowatt per hour, which is like on the low end of a residential refrigerator.
Mm-hmm.
Oh wow. That's really cool.
Yeah.
Okay. So you're walking the walk, you're in the talk, you're getting it all from every angle, obviously, so you're working on this efficiency both as the machine and the input output, right?
Yep. Yeah. I
Okay,
guess.
so
Yeah. Go
Go
ahead,
ahead.
Jorie. Sorry.
No, go ahead. The other thing.
The other requirements for this actuator that are kind of like a bit less important to us at this moment, but worth considering in the future, and will probably become talking points in the next episode, are packaging, which basically means like the size and the weight of whatever product we are selecting and how that fits into whatever machine we're designing. So that's something important to always be considering from my standpoint. And then any like feedback or like control capabilities, we need to determine what those are up front, so we know whatever product we're selecting can contain those. And then finally, very important is cost and lead time, which kind of roll up into one. So that kind of rolls out the requirements for this Z actuator selecting process, I guess. Yeah.
In your head, do you have like a list of what you think is going to work?
Yeah. I mean,
Yeah.
there's a lot of products out there that could potentially work. I've definitely started digging into like picking one, but in reality, it might come down to is like, okay, there's like a bunch of different products from a bunch of different suppliers that will work, and which ones can we get cheapest, and which ones can we get fastest, and which ones will hopefully come from a supplier who's going to support us in the long run. So yeah, it might come down to that.
What's your process then? You order a bunch and try them all, or?
No, the process is you try and do as much analysis upfront as possible. So basically that process is like you go to the website for the suppliers, you read through the manual, you do a bunch of calculations based on your requirements from the manuals, and you say, okay, this one's going to work with this motor, or this, this is the list of the ones that are going to work. I haven't quite done this yet. I've started it for 2 actuators, but I want to survey more. And then my process will be to pick the best from the list. And then from those best, I'll, reach out to the suppliers and see what they cost, see what the lead times are. And then probably go from there, have an internal discussion, some internal meetings, and make sure that everyone's aligned on the one that we're selecting.
Yeah.
And I'm sure we'll get to that
And this is where the vendor support becomes so critical as well, because every application has some amount of nuance, or certainly does, and oftentimes or like vendors that are easier to work with will have some sort of internal resource that could be like a technical sales engineer or they might even have some sort of internal calculators or even calculators on their website where they'll provide tools for you to help you in your analysis
Totally.
that are mapped directly to their products.
Mhm.
And that can help close that loop a lot faster, especially with
For sure.
the sort of inside technical knowledge that they have. Yeah, they're the
They're
experts
the
of their own
experts.
products.
Right.
Mhm.
And they can listen to our application details and guide us in the right direction.
Yeah,
That can,
Yeah.
that's a super
like,
important one.
yeah. I mean, I would think that every company would want want to provide that information and make it easy if they're a viable company.
Yeah, yeah, it really depends. It probably just depends on how the companies are structured and their
Yeah.
product lines look like.
Definitely.
Yeah, yeah, but they can provide like one of the nuances for us is going to be, like one of these things we talk about a lot are like peak spike or shock loads to
Mhm.
our system, and depending on the assumptions you make around that, it could radically change what product you spec. And it's one of these things it's could be difficult or impossible to do analytically up
Mhm.
front. You kind of just have to hopefully map it onto some experience using these actuators
Mhm.
and say like, okay, well maybe we should be thinking about peak or shock loads like this or like that. And
And
that's going to change the course we take.
yeah, that's where that nuance of like the supplier and the applications engineer and potentially like them being able to reach out to the actual manufacturer of the product comes into play. Is like they understand those nuances, like that's their job. So
Right.
it's our responsibility to get into contact with the right people who can help us answer those very like low level questions.
Right.
Yeah,
Right.
yeah,
Okay,
yeah.
so there's a little call to action then, if you are in supplier, reach out to Aidan.
Yeah,
Aidan at
yeah,
Urban
reach
Machine
out to me.
Build.
Yeah, there you go.
I mean, it's the power of social media. Hopefully, you get some people sharing this episode, and then they'll be like, "Hey, I know someone, or I have something."
Yeah, yeah,
Help us on
Always
our
looking for
journey.
good suppliers.
yeah.
That's right. You guys, this was great. I learned a little. I can't wait to see what happens the next time we meet. Episode 2 of Make the Bird Soar, Make Big Bird Soar. Um, we can look
Mhm.
for some ideas. Boiling, not just the problem, but what's happening next, right?
Yeah,
Exactly.
yeah. We'll have some contours of it. We'll have maybe some product info to share. Yeah, yeah,
More detailed requirements, and then hopefully some amount of analysis into like maybe some certain products.
yeah,
So
Okay,
yeah.
that's
I
awesome.
think that's
Very cool. Well, I hope you guys have a
sorry.
Yeah,
because between now and
right,
then
Right.
we'll have
it's gonna be a
Halloween.
meteoric Halloween. It's gonna be so good.
And if you want to anything more about Urban Machine, you can visit our website, urbanmachine.build. Reach out to any of us if you have some ideas about how to help us make the best robot possible for reclaiming wood.
Absolutely, yeah. And if you're excited about working on robots, we usually have some job postings open. So check us out on our website, the careers page. We'd love to hear from you.
That's right. All right. Thanks, everybody.
Yeah, super.
Take
Thank you.
care.